Welcome back, students. This video is going to be about power and mechanical energy. Okay, so it's just two equations, one for each of those. I had mentioned in the first video types of energy that mechanical energy is just the combination of potential and kinetic energy. So we'll go ahead and start with that. Okay, so here you can see the equation for mechanical energy is just potential energy plus kinetic energy. It's just the sum of both those energies. It's the total energy of the system, in other words. If I were to solve for either of these variables, all I would have to do is subtract the other one to both sides. If I wanted to solve for potential energy, I would just subtract kinetic energy to both sides. Okay, so then I get potential energy is just equal to the mechanical energy minus kinetic energy. And then vice versa, if I wanted to find kinetic energy, it would be the same thing, but they would just swap spots. It would just be potential energy is equal to the mechanical energy minus the kinetic energy. Okay, I'm going to go ahead and draw a picture now of an example that'll help you visualize what mechanical energy is in a particular system. Okay, here I've drawn an example where there's a bicyclist going through a very hilly path. At the beginning, he's at the max height of the path, and he has only potential energy and no kinetic energy. He has 10 joules of potential and then 0 of kinetic. As he starts going down the hill, his potential is being transformed into kinetic energy. So whenever he reaches the bottom of the hill, his potential is going to be 0 because the height at the bottom is 0 relative to the rest of the system, which means all of his energy is going to be in his kinetic energy at the bottom. Okay, and then as he goes back up another hill, where this hill is like halfway, that's the halfway height between the max height, then his potential and his kinetic are going to be evenly split, 5 and 5. Whenever he comes back down to the bottom, his potential is going to be transformed to the kinetic again, and it's going to be 0 and 10. Okay, but at any point of his path, the total energy of the system, or the mechanical energy of the system, is 10 joules, no matter where he is. So you can think of mechanical energy also as just the total energy of a system that looks like this. Okay, now I'm going to go ahead and move on to power. Okay, so whenever you hear the word power, you probably think of something that's strong, something that can apply a lot of force. That does kind of apply to the physics definition. In physics, we define power as how much work can be done over a period of time. So the equation looks like this. Okay, so it's a pretty simple equation. You just have power equals work divided by time, and the unit for power is watts. We just use a capital W to notate watts for the unit of power. I'll go ahead and do a quick example to calculate power. Let's say we want to know the power output of a sumo wrestler who is doing about 20,000 joules of work in 30 seconds. Okay, I would just plug in 20,000 here and 30 here. Okay, then I'll plug this in my calculator. The answer I get is 666.6 repeating watts. Okay, if I were to use this equation and solve for work or for time, I'd have to move things around to isolate either of those variables. Okay, to solve for work, it's only one step I need to do. Right now it's being divided by time. To get the time out of the way, I'm going to do the opposite of what's happening to it. So if it's being divided, then I'm going to do the opposite of that, which is multiplication. Okay, and then that just gives me work is equal to time times power. In the case when I want to solve for time, whenever I'm given power and work, I'd have to isolate t. And from this equation, I just need to do one step to find t by itself. If power is being multiplied to it here, I need to do the opposite of that and divide it to both sides. And then I can find that time is equal to work divided by power. Okay, I hope this video helps you guys understand the concepts of mechanical energy and power, and I hope it helps you figure out the Google form. Thank you guys. If you have any questions, let us know.